prediction with data mining classification algorithms. And I will be covering the introduction, the problem statement, objectives, literature survey, methodology, results, future scopes. Now, heart disease is one of the most fatal diseases in the current world scenario, and diagnosis for such a disease is done through various medical tests and their predictions. As healthcare is a significant area and a very sensitive area of research, every single wrong prediction may be life-threatening. The purpose of this dissertation was to investigate the reliability with which the machine learning classification algorithms can predict the onset of heart diseases. The heart disease database from the UCI repository was used to analyze various algorithms. The problem statement was to diagnose the data in order to achieve greater accuracy for the prediction of heart disease. The objectives are as following: to see whether machine learning classification algorithms will accurately predict heart disease, to predict heart diseases using data mining classification techniques such as naive-based, k-nearest neighbors, logistic regression, decision tree, and MLP, to figure out how to improve the model, compare the accuracy, and improve the data classification models. Earlier researchers concentrated on singular results of specific machine learning algorithms, but not by using any optimization techniques. For heart disease prediction using data mining techniques, some of these research gave valid results, and they haven't provided any optimization techniques. These are some other papers that show that the chances of developing coronary heart diseases was a certain percentage for males and 24.2% for females of the age 70 and 42.4. This is the proposed work. First, we get the data, then we load the data set, then we denoise the data, which is a pre-processing of the data. Then we train and test. We split the data into train and test portions, and then we apply certain algorithms, and then we evaluate the performances. The data set that we used was taken from Kaggle, a heart disease prediction data set. It consists of 4 databases, the Cleveland, Hungary, Switzerland, and Long Beach 5. It contains 76 attributes, including predicted attribute. And all published experiments refer to using a subset of 14 of them. The target field refers to the presence of heart disease in the patient. It is integer value, 0 is no disease and 1 is predicts disease. So the process of denoising the data was as follows. We checked the correlation between all the features and the target. We checked the F variance and P probability values for each one of the categorical features by using ANOVA. And basically, we wanted the F value to be as high as possible and the P value to be as low as possible. Thus, FBS fasting blood sugar column was removed. Then we checked for outliers by using box plots and removed any data outside the minimum and maximum lines. At last, finally, we removed those outliers out of the original 1025 rows. 947 still remained, and thus we did not lose much data. Results were similar for other classifiers in terms of accuracy, except for the MLP classifier. The algorithm used were decision tree, logistic regression, naive Bayes, k-nearest neighbors. For the performance evaluation, we used precision, recall, accuracy, and F1 score. These are the results that were given. For decision tree, the accuracy came out to be 0.79, the precision 0.78, recall 0.77, and F1 score 0.79. For logistic regression, it was 0.78, precision was 0.79, recall was 0.76, and F1 score was 0.78. For k-nearest neighbors, the accuracy was 0.83, precision was 0.83, and so was the recall and F1 score. For naive Bayes, the accuracy, precision, recall, and F1 score all came out to be 0.81, and for MLP, all the 4 performance matrices were 0.89. 0.98, I'm sorry. The results and discussions are as follows. The denoise dataset resulted in varied impacts on the performance of each algorithm. While some algorithms showed marginal improvements, the others demonstrated significant improvements, with every algorithm performing best with highest accuracy of 98% and balanced precision, recall, and F1 score, the three of them being 98%. The future scope is as follows. The work was carried out on a small data set, and in the future, larger data set could be used. The data set could be expanded further by compiling information about heart patients from hospitals across India and across the world. More feature denoising algorithms could be used to further fine-tune the data set. A hybrid model that combines some of the algorithms employed in the study could be used to create better results, and other machine learning and deep learning algorithms could also be used to get more accurate results. Thank you.